So a little bit about me. My name is Nick Schmidt, and I work for a small consulting firm based out of Philadelphia called BLDS. And what we focus on is statistical consulting around regulation and litigation. And in the past few years, my focus has been in working in AI, and in particular getting insurance companies and primarily financial lenders to be able to implement AI in a safe way and a non-discriminatory way. And as I have the caveat, I am not a lawyer. This is not legal advice. Take what you will from it. It's my experience and it's my knowledge. And it is a lot of experience working with both regulators and regulating industries. So one of the questions, can AI discriminate? And there was a long time when AI first got really big where people said, no, AI is so good that it cannot possibly discriminate. And I always was a bit skeptical about that. You have a model that we all accept could have bias, and it's got an AUC of 0.75. You've got an AI model that has an AUC of 0.8, and suddenly there's no longer any bias or discrimination. And that didn't make sense to me. And over the past couple of years, what we've seen is that, in fact, AI can discriminate. And so here we've got sort of one of the original results that's been shown as an example that AI can discriminate. And it comes from work that was done by a woman, I believe she was at Harvard. And this particular example came from a New York Times article called "Facial Recognition is Accurate If You're a White Guy." So what we have here are a bunch of nice white guys here, and we want to see how often gender was misidentified. 1%. 7% for white women. 12% for men of color, and a shocking 35% for women of color. Now, it's offensive, and it would be annoying if it were just a matter of your Google Photos being misidentified. But when you think of high-stakes applications of AI, this becomes a real issue. Think about it in terms of policing or anti-terrorism. These could have life-changing or potentially deadly implications. So why is fair AI important? I mean, I feel like it should be a relatively self-evident thing, but I don't think that everybody believes that it is. And one thing I want to point out, the first thing is positive impact on society. A homeowner in the US, or the median homeowner in the US has 80 times as high net worth as a renter. That's astounding, and that's something that's built up through generations. So for the lenders here who are building mortgage models, the effect of your models is profound on people's lives. Getting it right can lead people into the middle class. It can really change a person's family. And getting it wrong and not giving a person a mortgage who is deserving keeps them stuck may keep them stuck in a cycle of poverty. Then you get to the more sort of like what's in it for me questions, and you've got decreased regulatory risk, decreased reputational risk, increased market share and profit, and ultimately you're increasing your stakeholder value. There's been a lot of work. Lending Club, as an example of a lender, has used alternative data, and there was a Fed study that came out that focused on them, and it found that because they were using alternative data, they were able to penetrate markets that were for people of much lower credit quality than usually would have gotten loans. And even for the people who would have gotten loans, the pricing was much better for them. So having a focus on fair AI is good for you, it's good for the society, and ultimately it can be done in a productive and cost-effective way, and I'll show that. One of the big problems we face is that there are a lot of really good academics who are doing work on fairness in AI, but they don't know regulation. They don't know what's going on in US law. And what has happened is they've come up with a ton of different definitions of fairness, each one of which, if we were to go through them one by one, most of us in this room would agree that seems like a reasonable thing to do. That seems like a reasonable explanation for fairness. But it turns out when you put them all together, they're contradictory, and you can't optimize on one without degrading the other. And that's obviously problematic, and it's created this logjam where people don't know how to proceed, at least in the academic community. What I claim and what I work on is saying that sure, it's hard, but there's 55 years of legal precedent, Supreme Court decisions, laws, legal theory that's gone into all of this, and it's come up with a few really good definitions of fairness that I think we can all work with. And if that needs to be evolved over time, that's great, and I want to do that. I want to be a part of that, but let's start with that framework. And the goals of US anti-discrimination law as they stand right now are treat like people alike. Or the other term is treat similarly situated people the same. And then the other goal is to achieve parity in favorable outcomes across groups. So I'll talk about these. So disparate treatment is generally considered intentional discrimination. And that goes to that first definition of treat like people alike. And if you are discriminating against someone from a disparate treatment point of view, then you are not treating them fairly despite having similar characteristics. So it's, I won't give you a loan because you're a woman or Hispanic or Asian, or I'm going to make it harder for you to get a loan. In banking now, that is generally not something that we see in large lending institutions. They're very proactive in making sure that stuff does not happen. And so what ends up being a bigger issue is what we call disparate treatment. And disparate treatment is sometimes called unintentional discrimination, and it's actually kind of a hard concept to get. And what it is that you have what's called a facially neutral factor, or something that we can agree and the models can agree is a reasonable predictor of the outcome. So something like a credit score being a predictor of default. We know from decades of experience that credit score is in fact a good predictor of default. So it is a reasonable variable to include in most, if not all, models. But the problem with it is that almost all credit scores that I know of in almost all populations of people applying for loans will have a differential impact by race, and sometimes by gender, and sometimes by age. And the reason for that is that there are underlying differences in default rates by race. So African Americans and Hispanics tend to have on average, not individually, and that's very important to point out, is on average have higher underlying rates of default than do Asians and non-Hispanic whites. So if you've got a good model that incorporates credit score, what you're going to see is this disparate impact where African Americans and Hispanics receive loans at a lower rate. That may be illegal, it may not be. And over here in this example, what I'm showing is that nearly all of the women are below $4,500, and nearly all of the men are above $4,500. And what we're predicting is credit card spend in the next month. And we're doing that based on the average account balance in the current period. And banks typically use these kinds of models in order to determine things like how many airline miles are you going to get? Are you going to get a discount on some fees or things like that? And so what would happen is typically the more you spend, the better the outcome that you'll get. So the goal is, what you would love to be is up on the right-hand corner. But all the women, or virtually all the women, are below on the left. That means they're going to get fewer offers. So if average account balance turns out to be a reasonable predictor, and there are no other better predictors, then this model would be legal. There's another kind of bias that people talk about, and this has really become an issue in machine learning, though it's always been there and has kind of not gotten as much attention in the traditional statistic world. And that's this idea of local bias and differential validity. And here what I'm showing is that the error rates for the women are significantly different than those for men. And so women, their true values are much higher than their predicted values, which means that they are not going to get the offers that they should. But it's only for this small region. That is problematic, and it's no longer disparate impact as traditionally defined, because the reason why these errors, or the effect of these errors having a different distribution, is that line, the trend line, is not right for both men and women. It would be much more heavily weighted towards men, which ultimately would make women worse off. And so that's something we need to look at in machine learning, because there are all these little clusters of people, and you can have differential validity and differential and local bias without really realizing it. Reasons why AI might discriminate is in the data, there are underrepresentations of minorities. And in the facial recognition example, that's exactly what we saw happening. Inaccurate or missing data, this is always if it's correlated with race or gender or whatever. If those inaccuracies are correlated, then your model is going to be differentially valid and inaccurate. An example of this is a lot of lenders want to start using rental payments for people who don't own their own home. The problem is that African Americans, the coverage rates are much lower. So you're going to have significant missing value problems for them. And depending how missing value problems are dealt with in the model, you could have bias introduced by that. Differences in patterns of causation and correlation. That's a really important one that I think needs to be addressed, which is that blacks and whites and Hispanics, men and women, have different experiences, and the features as they affect the outcome can be different. And you have to take that into account, or else you're going to have bias in the model. And the last one is incorporating past or future discrimination. That is, as an example of that, African Americans are more likely to be discriminated against at their jobs. They're more likely to be terminated. And the biggest reason for defaulting on a loan is losing your job. So if you're incorporating expected job loss because you're using a historical data set, then you are going to be you're potentially, not necessarily, but you're potentially going to be discriminating against your customers before they've even had the chance to be discriminated against. And that's obviously problematic. And then the other reasons why AI might discriminate, and this is where I'm really going to get into what we do, is that there are alternative models available. And going back to that credit score example, credit score will have a differential impact on blacks and whites, or Hispanics and whites. And as a result of including credit score, what you're going to get is fewer African Americans are going to get loans. Again, I said that may be legal, but the question then becomes, is there a different model that is less discriminatory? And if there is a different model that is available that is less discriminatory, then you have an obligation to adopt that model. So instead of using credit score, could you use credit score plus credit score squared, or income and credit score, drop credit score altogether, and find a less discriminatory model? And that's what you need to look at. These are a couple measures of discrimination. I'm not going to go through them. The important point I want to make is that these are specific measures that are used very commonly in regulatory and legal settings. They are different than a lot of what you're seeing in packages that are being put out now. And if you're doing this work, you want to pay attention to to some of these and also understand the differences. What we do is we use AI to fix AI. That's kind of our tagline. And the goal is to find a fairer model that meets business necessity. So in my credit score and then credit score squared example is that we don't require you to adopt a model that's going to mean you lose money. What we need you to do is look for a model that's very similar, not necessarily quite as predictive, but very similar, that will still meet your needs but have less discrimination. And the great thing about AI that people didn't realize is that there's this multiplicity of good models problem with AI, which is you develop a model and it turns out that you've got 1,000 different models that all have AUCs within 0.02 of each other. Well, what does that mean? With lots of choices, you can now optimize on a second metric. So let's make that second metric fairness. And anytime you're trying to optimize on more than one metric, what your goal is to find the Pareto Frontier. And the Pareto Frontier is where you are getting the most accurate model for a given level of in this case, fairness. So you would never want to choose one of those gray models in the middle because you can always increase the fairness or increase the accuracy. So in this process, what you do is you set up your ideas of what am I willing to take in terms of a hit of inaccuracy, and then you find the models on that frontier and choose the one that is the most fair. How does this work? Pretty well is what I found. And this is a real-life example for a credit model that we worked on. And I was really proud of the results because what it showed was we were actually able to decrease disparate impact by 50% while still maintaining the model quality. The original model had an KS of about 0.371. And we were able to find an alternative that was in the high 3.9s. So a very small decrease in quality, yet a huge increase in the number of minorities and, in this case, female borrowers who would now get loans. There are a lot of different ways to be able to fix AI. And a lot of these are actually in the AI Fairness 360 toolkit that IBM has put out. I would caution if you're in a regulated industry, this stuff it's easy, but getting it right and not getting sued is hard. There's a lot of subtleties you have to understand. And so just using out of the box methods may not work. The different methods are feature selection, just choosing the variables. Algorithm selection, can you try an XGBoost or a random forest or a linear regression or anything else? Adversarial debiasing, which is kind of my favorite one. Data pre-processing, which I think is a really bad idea in a regulated industry. And regularization and hyperparameter tuning. And you can use some group of these to ultimately draw that Pareto frontier and choose among the models. What I want to talk about here is feature selection. One of the things that people have always said to me is, look, we've got a model with 1,000 variables. How can you possibly deal with that? Well, it's not that hard. What you do is you draw something like this, and this is where explainable AI comes in, is you look at the average class control differences, so the average black-white differences in the score. And what we have here is to the right is worse in terms of impact on the protected class. So in other words, over the 0.2, on average, any variable over here is driving African Americans up 20 basis points. And then on the y-axis, what we have is variable importance. And so the question becomes, what variables or groups of variables can we drop or add in order to try to make a fairer model that's reasonably predictive? And the color coding helps. You want to drop the ones in red, the low importance, high discrimination ones, and you would want to keep the ones in green. The ones in the middle are sort of cases that you don't necessarily know what they're going to do. You can try them and see what the results are. Then there are these dual objective function methods where instead of like feature selection is sort of external to the model, you're creating other models and then testing them. You can actually create unified single models that try and take care of disparate impact while it's being trained. And what it's doing is down at the bottom is it's creating a different loss function. So the final loss is equal to say the cross entropy minus lambda times the loss associated with the disparate impact. And you try and minimize that. And you play around with the hyperparameter until you get the results you're satisfied with. And in effect, what this does is that it gives you different choices, or it actually gives the computer different choices for what splits to use. So over here on the left, what we see is that the score is split at 660, and we've got an AUC of 70.5 and disparate impact of 65. 65 is reasonably bad. Over on the right, we've got an AUC of 60.1 and disparate impact of 95. We've almost achieved parity in terms of disparate impact. That's really great, but we significantly degraded the model quality. That's unlikely to meet that business necessity requirement. But in the middle, it tried a different split at 640, and it found that there was a slight deterioration in quality, but a reasonably big improvement in impact. And so it's likely that the model would choose that split, and if all else goes well, then the end result is a model that is fairer, that still has a good result. Couple parting thoughts. And one thing I want to say is everything I've said so far I think has been really negative. I think AI is awesome. I think machine learning is awesome. I think that the potential to reach new people, the potential to solve problems that were unsolvable before has just tremendously increased. But with that comes a huge responsibility that we all face to make sure that our models are doing what we want them to do and what we think they should do. And even if you have no ill intent when you're building your model, it is absolutely possible that your model could be discriminatory. So here are just a couple thoughts. Review your data closely. Think about your features. What is their relationship to the actual outcome? And another one is search for diverse views. When you've got 1,000 features, you don't know what those features are, how they're interacting with various elements of the population that you're modeling on. And having a good idea of what those effects could be and how they could be different within the immigrant community or within the African American community or so forth, it makes can make a big difference and can lead to or fix discrimination. And finally, you can fix AI. And we've shown it, and there are other companies that do it, and I think it's something that's worthwhile and very beneficial to society and you. So, do it.